So in order to perform the testing of hypothesis, whether it's a parametric, non-parametric, we need the library called SciPy, and from the SciPy, I am calling a module basically called stats. Okay. So, but before that, we also needed the libraries Pandas as PD, NumPy as NP. Similarly, for plotting the graphs, Matplotlib.pyplot as PLT, and then from SciPy, I am basically calling the library module stats. Okay, and this is the magic line. So first of all, I have loaded those libraries, and for the testing of hypothesis, basically I'm using a credit card usage example. So this is the basically the data set which I am using. If we are going through from this data set, this is basically the customer ID, its gender, where 0 is indicating the male, 1 is indicating the female. Okay, and then channel, the region from where it is, the marital status. One is basically indicating married and two is indicating unmarried. So there is a three type of customer segmentation we have divided, one, two, and three. Then we are mentioning that the pre-usage. Okay, so basically we have run a market campaign. So before that market campaign, what was the pre-usage level of the credit card? Then after 1 month of that market campaign, what was the post usage after 1 month? Okay, then after 2 months, what was the usage level? Similarly, what was the usage level the last month of the year? Okay, so exactly the last month, right? And we have basically this particular data set. Okay, so first of all, I have basically generated these six persons. So the first one is that the credit card usage has been improved significantly from last year, that is 50. So the claim is the from the last month is the usage level on average 50 or more. So that means the scenario is that we can apply either the one sample t-test, or either we can apply one sample Wilcoxon sign rank test, because we are going to compare the variable, that is the last month usage, to the average value, which is the target value, which is 50. But first of all, let's load this data set, and then one by one we will go through these six questions. Okay. So first of all, I'm going to loading this data set. So for that, I'm basically using my pandas library. So pd.read underscore csv. So I have given the path, and then I'm storing that data set into cc, which is credit card. Okay, and then after reading it, I am basically extracting its first 5 rows with the help of cc.head. Okay, so in order to see that data set. So the first thing I'm going to see is basically the data frame information with the help of info function, where I can see that the total number of data entries is 200, which is ranging, the index value is from 0 to 199. This is indicating the number of values. So all the values are there. So there is no missing value. We can also see the data type of every particular variable. Now, let's explore the first question which we were discussing. As we have seen that in this particular scenario, when we are want to compare the particular variable against the hypothesis or the target value. So we want to see that is the average last month usage is 50 or more than 50. Okay, so that's why I have developed the hypothesis that the average usage in the last month was exactly equal to 50, or you can say equal to or less than 50, whereas the alternative is more than 50. Okay, but in order to test this hypothesis, first of all, I am running the descriptive analysis. So descriptive analysis mean I am going to calculate the mean, standard deviation, the minimum and the maximum, which we can do with the help of this describe function. But we want to find out the descriptive analysis of the last month usage variable. Okay, so that's why from the cc, where we have the complete data set in this variable, So that's why from the CC, I am basically extracting a variable that is last month usage. So there is a two-way, either we can use this one or either we can use CC dot, okay, the latest month usage. Okay, so either you can use this approach. Okay, and then describe. Okay, describe function. Okay, so either I can use this approach to extract the variable and find out the descriptive analysis, or either I can use this one, which is the array perspective or the list perspective, where we are using basically the brackets, okay, in order to extract the variable and then describe. So I'm getting the descriptive statistics of that variable. So it is indicating the count, the mean usage, okay, the standard deviation, the minimum usage, okay, the median value, so first quartile, third quartile, the maximum usage. So from the descriptive statistics, we can see that the average usage is more than 50. Okay, so which means we are saying that accepting H naught, that the average usage in the last month is more than 50. But we cannot make the final conclusion based on the descriptive statistics. We have to perform the inferential analysis. So for that, what we are going to do, first of all, we are going to check the assumptions of the for the parametric test for that variable. And what was that? In order to apply the one sample t-test, we have to check whether the this particular variable do follow the normal distribution or not. So for that, first of all, I'm going to apply the probability plot. So for that, I'm using one of the function from the SciPy library. So that's why I'm saying stats. Okay, that is basically I'm calling this SciPy module stats. Okay, and then I am saying that probability plot, that is basically the function available in the stats module from the SciPy, and I want to check the probability, the more specific the normal distribution of this variable, whether this variable follow the normal distribution or not, then comma, then dist is equal to, so that the argument is stats dot norm. So we can check the multiple distributions, but right now I am interested in the normal distribution. And then plot is equal to plt, which means we want to draw the graph with respect to the matplotlib. Okay, then with the help of this one, we would be able to draw the normal probability plot. Okay, so let me run this one, so we can see that we have this probabilities, okay, as well as we have the probability plot. But what we are interested in, we want to only plot the exact normal probability plot. So I am saying that using the matplotlib, so there will be no x-axis label. So give the title of this one and show me the graph. So if I run this one, so we can see this probability plot. So how we can interpret this probability plot? If these blue dots are exactly lying on this red line, then we will say that the data do follow the normal distribution. But as we can see that over here, and few points on the top side as well, that they are not exactly lying on this red line, or they are not creating a straight line, then we can say that based on this graph, the data do not follow the normal distribution. But we can also apply a specific test in order to know whether the data follow the normal distribution or not. So for that, we have available a function called Saphiro, which is basically a Saphiro-Wilk test in order to know whether the data do follow the normal distribution or not. Okay. So how you can that check that? Stats dot Saphiro, that is the function, and then you can mention the name of the variable, okay, against which you want to check whether that particular variable follow the normal distribution or not. So if we run that, we will get the statistics of the Saphiro-Wilk test. We will get the p-value, okay, and what was the decision making criteria? Okay, generally, if I am going to write down over here, so the decision making criteria is if the p-value, okay, that is basically we are calculating from the data for the specific test statistics. If the p-value is greater than or equal to your pre-decided alpha, let's say, which is right now I'm considering 5%. So if this decision is right, we will say except h naught. Okay, except h naught. Okay, if the p-value is less than alpha, we will say do not accept h naught, or you can say the reject h naught, right? So remember that this is also probability, this is also probability, and this p-value is always calculated from the data, and this is the pre-decided value, or you can say this is the type 1 error. So which means we can say that whatever the decision we are taking, we already know how much error in that decision. So if I am saying the alpha I am considering is 5%, which means I am saying that whatever the conclusion I am drawing, I am in that decision there is a 5% error, and if I'm using alpha 1%, so there is a 1% error that I am going to take the wrong decision. So in uh, another scenario, we can say that if alpha is 1%, which means I'm 99% confident about whatever the decision I have taken. So in this case, what is the H naught? The H naught is the data do follow the normal distribution. Okay, do follow normal distribution. Whereas H1 is the data do not follow the normal distribution. Do not follow normal distribution. So as we can see that, okay, uh, this p-value is 0.002, which is basically less than 5%. So we can conclude that the data do not follow the normal distribution. So the same thing which was mentioned by the probability plot, the similar kind of result we can find out from the Spiro-Wilk test. The data do not follow the normal distribution. But as we have seen that the number of counts in this particular dataset is 200, and normally the statistician says that if the sample size is large enough, like the 200, okay, so we can relax this assumption of the normality of the data. Okay, so that means in this particular case, we can apply both. Either you can apply the one sample t-test, or even you can apply the non-parametric as well. So that's why what I am going to do is I'm going to apply both the parametric as well as the non-parametric. So first of all, I am basically applying the one sample t-test, and for in order to apply the one sample t-test, we have a function called t-test underscore one SAMP from the SciPy library module stats. So that's why I'm writing down stats dot t-test underscore one sample and name of the variable, and then comma the argument is pop mean, which is the population mean, is equal to 50. That was the target value which we were mentioning over here. Okay, so if I run this one, I am getting the p-value is, which is 2.49 e per minus, which is almost zero. So again, the decision making criteria is the same one, because this p-value is less than 5% or even less than 1%. So which mean we will say reject h naught. And what was the reject h naught? That was the average usage in the last month was 50 or less, you can say that, because the alternative is greater than 1, greater than 50. So because the h1 is accepted, so which mean the average usage of the credit card in the last month was more than 50. Okay, which we also have seen from the descriptive as well. But remember that the final conclusion we are going to take based on the inferential analysis. Okay, so let me also find out the confidence interval. So how you can do that? From the this command, you can write down dot confidence underscore interval, and then you can mention the level of the confidence. Okay, so either you can mention 95, or you can say 99 confidence level. So if you run this, it will going to calculate the confidence interval against that confidence level, right? So if I am mentioning 95, which means the alpha was 5%. So right now you can say that I'm 95% confident that the average usage of the credit card going to be like between 61.6 to 64.7. Okay, so as I mentioned earlier that against the same scenario, we can also apply the non-parametric. So against the one sample t-test, what kind of non-parametric test we have? We have one sample Wilcoxon sign rank test. So how we can do apply that one? So remember that Wilcoxon sign rank test is always apply on the difference of the variable. So how can I calculate the difference? So first of all, I will take the hypothesized value, which was the 50. So what I'm going to do is I'm going to subtract this value from the original variable, that is the last month usage. So that's why I'm saying CC the variable minus hypothesized value. So first of all, I'm calculating the uh, difference of the variable against that target value, and then I'm applying the one sample Wilcoxon sign rank test. How can I do that? From the SciPy stats module. So I am calling a function stats Wilcoxon. So if I run this one, you can also see that the p-value is less than 5% or even less than 1%. So the same conclusion we are getting. So that is basically the reject edge knot, which means the usage level of the credit card is 50 or more. Okay, that means except H1, right? So I hope you got the idea regarding the one sample t-test as well as the one sample Wilcoxon test. Now, the second hypothesis we have that we want to know that the last month campaign was successful in terms of the usage of the credit card. Okay, so which means if we are, can see that from our data set, we have the pre-usage of the market campaign as well as the post-usage 1 month and post-usage 2 months. So we want to know that is the pre-usage is and the post-usage, is there on average any difference in the usage level of the credit card or not? Okay, so we will compare pre-usage and post-usage 1 month, pre-usage and post-usage second month. Okay, so in order to know whether they are different or not. Okay, so that means our h naught is the pre-usage is equal to the post-usage. We will check against the both 1 month you after post usage 1 month and as well as the post usage for the second month. Okay, so first of all, again, I'm calculating the descriptive analysis against all three variables: the pre-usage variable, post-usage 1 month, post-usage 2 month. So if I'm going to calculate a descriptive analysis, we can see that the counts are 200. The average usage of the credit card before the campaign was 52.2 for the post usage of 1 month, that is 52.7, which we can say that it is look like there is no significant increase. Okay, which means there is no significant change even after the 1 month of the campaign, but we can see that there is a shift after 2 months. So there is an increase in the usage level. Okay, the standard deviation is there. So by the way, we can conclude that based on the descriptive analysis that after the campaign of the 2 month, so there is a significant look like increase. But once again, we cannot make the final conclusion based on the descriptive. We have to perform the inferential analysis. But before applying the inferential, let's plot it. So what I am doing is I am basically plotting the pre-usage and the post-usage after 1 month of the campaign. So for that, I have picked the plot of box plot. I'm going to use the Matplotlib in order to draw the graph. So first of all, with the help of this particular command, what I am doing is I'm developing a frame. Okay, and in that particular frame, which I'm storing in a variable called fig, and then in that frame I am adding a subplot at a position of first row, first column, and the number of plot, which means the plot number one. Only we are plotting one plot. Okay, and then I am saying that on that subplot, which is basically AX position. Okay, so draw the box plot. So here are the two variables. The pre-usage is one. Use this variable for the first plot. This one is for the second plot. And then in order to label these x's, we have to use this particular function, which is called as x's dot set underscore x tricks labels. So we are saying that give the label of pre-usage and then give the usage of post-usage 1 month. Okay, and this is we are giving the title of the y-axis with the set y label. So and then we are saying plot show. So right now you can see that these are the labels, this is the credit card, and this is the box plot. So how you can interpret it? So as you can see that this is basically the median usage before the campaign. This is the median usage of post campaign, not the mean but the median value, which is look like approximately the same. Okay, as well as the height of the box is also look like almost the same. So it seems that there is no significant change after the 1 month of the campaign. Okay, but let's again applying the inferential analysis. So once again, before applying the inferential analysis, let's check the distribution of the data of pre-campaign as well as the post-campaign of 1 month. So I again apply the Sapiro-Wilk test of the pre-campaign. So the p-value is indicated that data do not follow the normal distribution. The post campaign of 1 month is also not following the normal distribution, so which means we can apply the non-parametric. But again, because the sample size was 200, so we can also apply the parametric, which means the pair t-test. So again, I am applying the both one. So first I will apply the pair t-test for the pre-campaign and the post usage of 1 month. And in order to apply the peer t-test, the function we have from the SciPy stats module, that is t-test underscore rel. Okay, so stats underscore t-test underscore rel, and then the name of the variables. So again, if you can see this p-value, which is 0.38, which is greater than 5%, so we will say except H naught. That means the average usage, the average credit card usage before campaign and the average credit card usage post 1 month the post usage of 1 month is on average equal. But let me comment on this one. Okay, and then let me check is the average usage pre campaign, before the campaign, and the post campaign of the 2 month are equal or not. Okay, so if we run this one, so we can see that the p value is less than 5% or even less than 1%. So we will say reject h naught. So reject h naught mean that the pre campaign and the post campaign, the average usage level is not equal. So we can also check from here as well. If I am going to use the second month, and this should be the title as the second month. Okay, if we run this one, so what I have done, the okay, so this is basically the post uses the p is the small one. Okay, so if I run this one, is the okay, the spelling was the missing, this was the second. Okay, so now we can see that the average post usage was much higher compared to the pre-usage, as we have also seen from the test as well that the pre-usage and the after the campaign of the 2 month, the usage level is not equal, and we can easily see that after the campaign of the 2 month, the credit card usage is significantly increased. Okay, so let me uh, reset it to the original values. Okay, so this one is also same one. Okay, so again, because we have seen that against the two pair t-test, we can also apply the if the data do not follow the normal Wilcoxon test, pre-usage and the post-usage one. This is also giving us that the pre-usage and the post-usage after 1 month they are equal. So you can also check against the 2 month as well. That is definitely is going to be showing us that the data they are not equal. That means the post usage is higher compared to the pre usage. Okay, so like as we can see that the p value is less than 5%, so which means reject h naught. That means from the box plot as well as the descriptive analysis we can check that after the campaign of the 2 month, the usage level of the credit card is significantly increased. Okay, now we are discussing the third scenario, that is there any difference between the male and female in terms of the credit card usage? Okay, so both the groups are independent, so we can apply the two sample independent t-test if the data follow the normal distribution. But if the data do not follow the normal distribution, we can apply Mann-Whitney U-rank test. Okay, what was the hypothesis? That the average usage of the credit card among the male and the female are equal, whereas alternative is not equal. So first of all, I am calculating the descriptive analysis for the male and the female. For that, I'm basically using a function called group by from the Pandas library. So I am saying that group by with respect to the sex variable, which is basically our male and the female, where 0 is indicating male, 1 is indicating female. And I am extracting from the entire data set this particular variable, which is post usage 1 month variable, and I'm calculating the descriptive statistics, and in order to know whether the usage level for the male and female are equal or not. So for that you can either use the pre-usage, you can also check the post-usage for 1 month, as well as you can also use the variable the second month in order to check this hypothesis. Okay, so for the post usage 1 month, we can see that the average usage in male is 50, the average usage female is 54. It does look like that the average usage in the female is higher compared to the male, as well as we can also see the standard deviation value. Okay, so in a female, the variation is less compared to the male. Okay, now let's draw the box plot in order to know the average as well as the variation perspective. So for that, again, I'm using the Matplotlib. So for in order to draw the box plot using the Matplotlib, we need two type of list, or you can say array. Okay, so first one is I am basically extracting the male data from the entire data set, that is which we have the earlier one. So I am slicing the male data separately as well as the female data separately. So how can I slice, you can say subset the male data. So I say that CC post usage 1. So that means from this variable pick only those data points against we have the sex variable is equal to 0, which means only the male data. So I am storing this data in a variable called male underscore spend, and then sex is equal to 1 for that variable. Okay, and that is we are saying the store in that data in the female spend, and the rest of this one is the same which we have already seen earlier. The only difference is obviously we are changing the variable's name. So right now we can say that this is basically male spend, this is basically the female spend. Okay, and we can plot this graph. So from the graph as well, we can see that the average usage of the credit card in the female is higher compared to the male, as well as we have also seen that the variation in the male is higher compared to the female, and from the box plot we can see that, and that variation from the mean value or from the median is lower and is more compared to the high, which means there are more male which is spending lesser, using the credit card lesser. Okay. Uh, so if we are going to compare with the female, that with respect to average as well as the variation, so we can see that the female is using the credit card more compared to the male. So now let's apply the inferential analysis. Again, I'm finding that the male spend using the spherable test, the data do not follow the normal distribution. Same is case for the female. Okay, so which mean we cannot apply the two sample independent t-test if we strictly saying that the data must follow the normal. As we have seen that for this particular case study, we do have enough data set, then we can apply the parametric. But again, for this set, I will apply the two sample independent t-test as well as the non-parametric as well. But if I want to apply the two sample independent t-test, the second assumption I need to check. Okay, what was that? The variance between the two groups, the male spend and the female spend, must be equal or not. Okay, so how you can do that? We can check that with the help of Bartlett test or with the help of Leibniz test. Okay, so the function in order to check the equality of variance, one is the Bartlett test, another is a Leibniz test. Okay, so the function is Bartlett. Okay, the first variable, the second variable. So the p-value is 0.19, which is indicating, which is basically less than 5%, or but we can say that it is greater than 1%. So we can say that the data, it looked like from the Bartlett test that the both the groups variances are equal. But from the Leibniz test, it is look like that the variances are not equal. Okay, so which means if you are going to apply the two sample independent t-test, so how you can remove this confusion? So usually people are saying that if the data follow the normal distribution, then we can rely on the results of the Bartlett test. If the data do not follow the normal distribution, then we can rely on the Leibniz test. So we have seen that the data do not follow the normal distribution. So which means we can rely on the Leibniz test, and the Leibniz test says that both the groups having variances are not equal. So that means we can apply in this particular scenario two sample independent t-test with Welch approximation. But I have applied both. So if you want to apply the two sample independent t-test with equal variance, so the command is you can use stats dot t-test underscore ind, which means independent. The first variable, second variable equals is equal to true. So with the help of this one, we are saying that the average spent by the male and the average credit card spent by the female are equal. Okay, so with the help of this p-value, we can conclude that because this p-value is less than 5% or even 1%, that the average credit card usage or the spend is not equal among the male and female, as we have seen that the female are spending more. Okay, so let's apply the two sample independent t-test with Welch approximation, which means when the variances are unequal. Okay, so that's why instead of writing true, we are writing down the false. Now we are applying the Welch approximation test. The rest of the command is same. So with the help of Welch approximation, we are also getting the same conclusion. The p-value is less than 5%, which means reject H naught. That means the average spent by the male and the average spent by the female are not equal. Okay, so that means the female is spending more, as we have seen from the descriptive. So same is the case if we can also apply the Mann-Whitney test because the data do not follow the normal. Let's check what's the Mann-Whitney test saying about this hypothesis. So for that, we have the function called from the stats module, stats.Mann-Whitney U. Okay, the variable male spend and female. So again, the Mann-Whitney test is also saying that the average spend by the male and the female are not equal. And from the descriptive, we have seen that the female is spending more compared to the male. Now let's move towards the the fourth one. Now we want to check that is there any difference between the segment of the customer in terms of the customer usage. So we have different type of customer segmentation. So there is a three type of customer segmentation. So as you can see that the segment 1, segment 2 and segment 3. So we want to know check that is the average usage among different customer segmentations are equal or not. So for that, again, we have the qualitative variable in the segment, that is the independent variable, and the quantitative, either we can use the pre-usage or the post-usage or the last month usage or the post-usage second month as a dependent variable. Use one of them. Okay. So what I am going to do is uh, in order to apply the one-way ANOVA, so I will use the last month usage as a dependent variable. So our hypothesis is the average usage in segment 1, 2, and 3 are equal, whereas in alternative we have that at least one of the segment is different usage level compared to the others. So in this case, either we can apply one-way ANOVA if the data follow the normal distribution. If the data do not follow the normal distribution, we can apply Kruskal-Wallis H-test or the Moore's median test. As I mentioned earlier, if the data do have the outliers, then prefer Moore's median compared to Kruskal-Wallis. If the data do not have the outliers, then we can apply Kruskal-Wallis. But we are going to apply all three tests. Okay. First of all, again, I'm applying the descriptive analysis on by using the group by, that is on a segment variable, and then on the last month I am calculating the descriptive statistics. So the average usage in segment 1 is 60, this is 68, this is 55. From the descriptive statistics, we can say that the segment 2 customer using more compared to the other one. Okay. But again, we have to apply the inferential analysis. But before that, so using the same concept which I have used for the gender, which means for the sex variable for the male and female. So I am sub setting the data set or slicing the set, which means I am extracting the segment 1 variable, I am extracting segment 2 variable, I am extracting segment 3 variable, and now using these three variables, I am plotting the box plot using the same idea which I have used in the gender. So as you can see that, so there is a segment 2 customer average usage is higher compared to other one. Whereas in the segment 3, there is a one customer who uses the credit card more compared to the other one. As we can see, this is basically outlier in the segment 3. Okay, but in order to apply the one-way ANOVA, we again have the two assumptions. One is all three variables must follow the normal. So as we can see that this is not following the normal. This is following the normal because the p-value is greater than 5%. This is also the normal. So again, I will apply both one-way ANOVA and two-way ANOVA, but one parametric and non-parametric one. But in order to apply one-way ANOVA, we need to check whether the variance among these three segments are equal or not. So for that, first of all, again, I am applying the Bartlett test. You can also apply the Leibniz test. Against the center, you can write down mean and median. So it's up to you against what you want to see. Apply that one. So against the Bartlett, it is saying that the variance among all three segments are equal. The same is the Leibniz test is going to say that. So which means we can apply one-way ANOVA with equal variance. Okay, so how you can do that? So for that we have the test called f underscore ANOVA, and then we can write down the name of those variables, okay, which we want to compare. So as we can see that from this p-value, reject edge not. That means the average usage in all three segments are not equal. So there is all one, at least one segment which is different from the others. So in order to know which segment is different from the other, So for that, after the one ANOVA, we always apply the post hoc test. And what was that? That is basically we can apply Tucky test. So there are other post hoc tests, but the most famous one is the Tucky's test. So again, how we can apply this Tucky test from the SciPy module stats. So there is a function called tucky.hst, then all three variables. Okay, I'm storing in the Tucky variable and then print Tucky. So now this 0 is basically indicating segment 1, 1 is indicating segment 2, 2 is indicating segment 3. And against that, you can see that the p-value. Okay, if the p-value is greater than 5%, so we can say that both the segments on average equal. Okay, if the p-value is less than 5%, we will say that the average usage in both the segments are not equal. So as we can see that the segment 1 and 2, the average usage is not equal, but segment 1 and 3 might be possible because the p-value is greater than 5%, the average usage level are equal, whereas 2 and 1, the average usage is not equal, as we have seen earlier as well. Okay, so there is other way. So you can use another library in order to apply the Tucky test, which is basically giving us the more sophisticated table, or the our results output is a good one. So what was that library? That is basically the stats model. So from the stat model, there is a module called stats, and in a stats, there is a module called multi-comparison, which is basically multi-COMP. And from that, I am basically calling a function, or you can say module, which is pairwise Tucky HST. Okay. So from this library, or from this module, we are calling this pairwise Tucky HST. Okay, and then I'm calling that function and applying on basically this was basically the dependent variable. Okay, and group is equal to this is basically the you can say the independent variable, and alpha is 0.05, which means alpha is 5%, so you can also reduce it to 1% as well. So with the help of this one, so we will check against, we will get the same result, but the now the representation is much better. So you can see that segment 1 and 2, the reject h naught, which means they are not equal, whereas 1 and 3, so this is saying we are fail to reject h naught, that means the p value is greater than 5%, which means segment 1 and 3, they are equal. Okay, on average usage in those two segments, whereas in segment 2 and 3, the average usage is not equal. Okay, so I hope you got the idea one way NOVA, and after that we can also apply the Tucky test. So let me apply against one way NOVA. We can also apply the non-parametric test. Either you can apply a Kruskal-Wallis edge test. So for that we have from the SciPy we have a function called Kruskal. Okay, so the Kruskal also saying that all three segments, the usage level of the credit card in all three segments are not equal. So if you would like to apply the Moore's median test in the same scenario, the function is median underscore test. So this is also saying that the average usage level is not equal in all three segments. Okay. Okay. So the fifth one is, now we would like to know, is there any relationship between the region of the customer and the segmentation? So both are the categorical variables. Okay, so we have the categories are the segment 1, 2, 3. So we will consider them as a qualitative, as well as the regions, or although these are number, but we are going to consider them as a qualitative. So we want to know that is there any association or the relationship between those two factors. So because both are the qualitative, so we can apply in this that case is the chi-square test. Okay, so what was the chi-square? The H naught is there is no relationship between the customer region and the segmentation, whereas the H1 is there is a relationship. So first of all, in order to apply the chi-square test, I am basically developing a cross tabulation. So the cross tabulation is on y-axis, which means because I am mentioning region Second one, the customer segmentation is the first one. So row wise, we have the customer satisfaction, and the column wise, I want to display the region. So for that, basically from the pandas, there is a function called cross tab, and then on the row wise, what kind of variable we want to mention, that is the customer segmentation, and then I am extracting the region, and the margins are equal to true. Basically these are indicating the margins. So if you are, you can also check if we are going to write down instead of the true, what kind of difference we will see. Okay, so if this is the false, so you can see that there is, the margins are not showing. Margins means the sum of row wise as well as the column wise, it is not showing me. If I'm going to write down true, okay, if I'm going to write down true over here, okay, and then if I run it, you can see that this sum row wise as well as column wise, it is also showing me. So right now it is indicating there is a 16 region and one segment. So the total 45 customer lies from the segment 1, 47 comes from the region, and out of these 16 are basically the common one. Okay, and this is a cross tabulation. So now we would like to apply. So this is normally called as the observed frequencies. So we want to apply the chi-square test, and for that we have a function called chi2, which is chi-square underscore contingency, and observed is equal to ct, which means in which particular variable we have the cross tabulation variable table. So that is we are mentioning in the ct variable. So if we run this one, so this is basically the expected frequencies. Okay, so this was the observed frequency. These are the expected frequencies. So we will check that the p-value. So this p-value is 0.05, which is greater than or equal to 5%. So we will say except h0. So what does that mean? There is no relationship between the region as well as the segmentation. Okay, all right, in terms of the usage of the cards. Okay. Um, so now the last one is there any relationship between the credit card usage in the last month and the pre-usage of the campaign? So because now we are talking about these two variable, last month usage as well as the pre-usage, both are the quantitative, which means we have to apply the correlation. So H naught is there is no relationship, whereas H1 is there is a relationship. So before applying the testing of hypothesis, I am calculating the correlation coefficient R, and we know that R is always lie between -1 to +1. So the function is basically, this function is I'm using from the NumPy library. So NP CORRCOEF, which is the correlation coefficient. So this is the first variable. The second variable, so we will get this correlation coefficient. So the diagonal values always lie 1. So this is the basically the correlation coefficient among these two variables. So we can see that that there is a almost 62% there is a relationship between these two variables. So we can say that when there is a 61% of the time when the in the post usage variables, the value increases. In the last month usage is also increases, or you can say that when the 61% of the time in the post usage of 1 month campaign is decreases, the last month usage is also decreases. Okay, so in order to apply the test, so from the SciPy we have a called Pearson R, okay, and then those variables from the SciPy. So if we check this hypothesis which is less than 5%, we will say reject H naught. So that means there is a relationship between the last month usage and the post month usage variable. Okay, so the conclusion, what we have seen based on this case study of the hypothesis as well as the testing of hypothesis, that the average usage we have seen from the last month was more than 50. Okay, as well as we have seen that the after the campaign from the pre-usage as well as the post-usage of 1 month. And the post-usage in the second month, the usage level of the credit card is increased. Mostly the usage level in the female customers are more compared to the male customer, and the segment 2 customers are using more credit card compared to other two segments, and there is no relationship whether the customers, no matter which segment or which region they are coming from. Okay, so that doesn't matter. And lastly, there is a relationship between the usage in the last month as well as the post usage. So there is a significant relationship. So I hope you got the idea what was the how we can apply the testing of hypothesis in Python using those libraries, as well as you got the idea under what condition which kind of test we can apply. So thank you so much. See you in the next video.